Welcome to this lecture. Now we are going to discuss about the four conditions that lead to a deadlock. In operating system, a deadlock is a situation where processes are not able to complete its execution because of the scarcity of resources. Resources will be there in the computer, but that will not be allocated to that particular process. So processes will be starving forever. The system will not move further. This situation is known as a deadlock where your system hangs. Now we will see which are the four conditions that cause a deadlock. The four conditions are mutual exclusion, hold and wait, no preemption, and circular wait. What is mutual exclusion? It is the condition that only one process can use a resource at a time. Consider the printer. Printer is a resource that can be used in a mutual exclusive way. What does it mean? Suppose we have 5 print requests. Suppose first print request is to print 5 pages. Second print request is to print 6 pages. Third print request is to print 1 page. And fourth print request is to print 10 pages. So, can we print all these print requests or all these pages simultaneously? Never. The printer will print the first document which is having 4 pages first. After that, the second print can come out. That means the printer is a resource that can be shared but not used simultaneously by different processes. Processes can use a printer one after another. So, the printer should be released by the first process to be used by the second process, not simultaneously. Okay. So that condition is known as mutual exclusion. Now the second condition is hold and wait. In this condition, the process will be holding some resources and this process will be waiting for resources. And unfortunately, the waiting resources is held by someone else. Third condition is no preemption. This condition says that we cannot forcefully release a process from a resource. The process must voluntarily release a resource by its own. This condition is called no preemption. And the fourth condition is circular wait. Suppose that we have n processes P0, P1 up to Pn. They are waiting for resources held by another process. Let us assume that P0, process P0 is waiting for a resource held by process P1. P1 waits for resource held by process P2. P2 is holding for some resource which is held by process P3. In this situation, if P3 is eventually waiting for any resource held by P0, none of the processes will be able to complete execution, isn't it? This condition is called circular wait. So, to get more clarity, let us consider one example in real life. So, this figure shows a traffic scenario. We see 4 junctions and the traffic. Vehicles are passing through these junctions. Let us call this junction as junction J1. Let us assume this as junction J2 and assume that we name this junction as J3 and this is junction J4. Now, this is the traffic that passes through junction J1 from top left, the traffic on top left position. Let us name it as traffic T1. Traffic T1. So it is clear that the traffic T1 is now crossing through junction J1, isn't it? Yes. So you can say that traffic T1 is holding junction J1 now. What about junction J2? Which traffic is passing through junction J2? Yes, this one. From the right side to the left side. This traffic, we can name it as traffic T2. Now, which traffic is holding traffic junction J3? J3. J3 is held by the vehicle passing in this direction, and we can call these traffic as traffic T3. Now, what about junction J4? Junction J4 is currently held by the traffic coming from this direction, and we will name it as a traffic T4. These vehicles are now crossing the junction J4. They are holding that junction. At this particular instant, you can see that none of the vehicles are moving forward. There is a deadlock. Now I will show you all these four conditions are existing in this scenario. Take the first condition. What was the first condition? Yes, mutual exclusion. This traffic T1. Vehicles in traffic T1 is passing through junction J1. At this point of time, vehicle of traffic T2 cannot cross these vehicles. There will be accident. They cannot cross like that. Which means that only one traffic can access one junction at a time. This situation is known as mutual exclusion. So, traffic T1, T2, T3, T4 are the processes here, and the junction J1, J2, J3, J4 are the resources. So, that is mutual exclusion. So, in all these four junctions, mutual exclusion is there. What was the second condition? The second condition was hold and wait. Let's see that concept. So, consider junction J1. Actually, junction J1 is currently held by traffic T1. And what happens? Traffic T1 is currently holding junction J1. It is passing in this direction, and traffic T1 is waiting for junction J3. Isn't it? Traffic T1 is waiting for junction J3 to become free. Yes, only if junction J3 is free, traffic T1 can pass. Isn't it? Yes. So, traffic T1 is waiting for junction J3 to become free. Now, look who is holding junction J3 now. Yes, junction J3 is held by traffic T3. At the same time, traffic T3 is waiting for junction J4 to become free. But unfortunately, junction J4 is currently held by traffic T4. So what happens? Traffic T4. Now, traffic T4 is waiting for junction J2 to complete, or junction J2 to become free. But unfortunately, what happens? Traffic T2 is holding junction J2. Traffic T2 is holding junction J2. So, traffic T2 is holding junction J2. Now what happens? This traffic T2 is waiting for junction J1 to become free, and who is holding junction J1 now? Yes, traffic T1. So, we will draw this arrow back to traffic T1. So, what you see here is a circular wait condition. T1 to T3 to T4 to T2, then again back to T1. This condition is called circular wait. Then, what is called hold and wait? We have already seen here. Traffic T1 is a holding junction J1. and waiting for junction J3 to become free. This condition is called hold and wait. Process is holding some resource without giving to anybody else, and he is waiting for some resources to become free. Does this situation happen only in operating systems? No, it happens in real life. One example is this. Consider another example. Suppose two friends are there and there is a bowl of soup and there is one fork, one spoon, just one spoon is there. So there is only one. Now, what is the no preemption condition existing in this traffic scenario? Suppose junction J1 is currently held by T1. If it is free, then traffic T2 can easily pass through this junction. So, for that, we cannot take a car from traffic T1 using a crane and keep it aside and let traffic T2 pass through this junction. You cannot do like that. Traffic T1 has to voluntarily release junction J1. Then only traffic T2 can pass through this junction. This condition is called no preemption. You cannot involuntarily take a car using a crane and keep it aside and make the junction free. We cannot do like that. You cannot preempt that resource. So that condition is called no preemption. Does deadlock happens only in operating systems? No, it happens in real life too. This is one example of the traffic. Another example is, consider that you and your sister is at home and your mother has prepared tasty soup for you. For eating the soup, you have just one bowl and one spoon at home. Both of you require the bowl and the spoon to eat the soup. But what happened is, your sister took the bowl and you took the spoon. And you asked your sister, I am the eldest person, give me that spoon, I need to eat the soup, and then you eat the soup. But your sister is not ready to sacrifice. She told, give me the bowl, then I will eat the soup first, then you can eat the soup. So both of them is not ready to release their resource. They are not ready to release their bowl or their spoon. What happens? At the end, none of them is able to eat the soup. So that is a simplest case of deadlock happening in our real life. I hope these concepts are clear to you. That's the end of this video. Thank you.